For this tutorial, ituturo ko sa inyo ang law of conservation of momentum. So, sinasabi sa law of conservation of momentum, ganito. For a collision occurring between object 1 and object 2 in an isolated system, the total momentum of the two objects before the collision is equal to the total momentum of the two objects after the collision. That is, the momentum lost by object 1 is equal to the momentum gained by object 2. Okay, so ang pinag-uusapan natin dito is collision or alam natin sa Tagalog, ibig sabihin ng banggaan. So basta meron kang collision na meron kang banggaan between two objects, kung ano yung momentum nila before sila magkabanggaan, yung total momentum nun is the same pa rin kahit after na sila magkabanggaan. Nangyayari lang to, remember, kapag meron kang tinatawag natin na isolated system. So kapag sinabi natin isolated system, ibig sabihin nun, number one, wala tayong friction, or wala tayong mga other forces or wala tayong external forces maliban doon sa forces na ine-exert ng dalawang object natin na nagkabanggaan. So, kailangan natin i-assume dito na walang ibang forces acting on that system maliban doon sa force na ine-exert ng dalawang object natin na nagkabanggaan. Now, in this case, sinasabi rin natin na kapag meron kang law of conservation of momentum o pag sinasabi natin that the momentum is conserved, ang ibig sabihin nun, kung ano man yung momentum na nawala, let's say doon kay object number 1, yun naman yung amount of momentum na nag-gain or nare-receive ni object number 2. So, kumbaga parang palitan lang sila ng momentum. So, kung ano yung nabawas yung sa isa, madadagdag lang siya doon sa kabila. Pero pag kinuha mo yung total, the same lang din yun. So, ang law of conservation of momentum, kapag sinulat natin to sa equation form, ganito lang siya. This is the P before is just equal to the P after. Ang P is the symbol na ginagamit natin for momentum. Okay? So, sa ibang textbooks makikita nyo dyan, may delta dito. Ibig sabihin, yung change in momentum before collision is equal to the change in momentum after collision. So, sa iba naman, mga textbooks, ang ginagamit instead na after, okay, ginagamit dyan is ganito. Delta P is equal to delta P prime. Pag may prime, ibig sabihin nun, yun yung value niya after the collision. So now, gamitin natin tong formula na to sa pag-solve ng physics problems involving collisions. A 3,000 kg truck moving with a velocity of 10 meters per second hits a 1,000 kg parked car. So the impact causes the 1,000 kg car to be set in motion at 15 meters per second. Assuming that momentum is conserved during the collision, determine the velocity of the truck immediately after the collision. Okay, so kukunin natin muna yung given para sa truck. And then after that, kukunin natin yung given para sa car. So para hindi tayo malito, gagamit ako ng subscript. So gagamitin ko yung MT para dun sa mass ng truck. So ang mass ng ating truck is 3,000 kilograms. Okay? And then, yung velocity ng ating truck before the collision, okay, ang sabi dyan, nagmo-move daw siya initially at 10 meters per second. Now, be very careful sa paggamit ng mga signs kasi depende yung sign natin sa velocity kung yung object natin is kung ano yung direction ng kanyang movement. So, pag sinabi sa, let's say, sa problem na nag-move siya in the opposite direction, so kailangan ang gagamitin nyo na value for the velocity is negative. Okay? So, next, isusulat na natin dito yung given para sa velocity of the truck after collision. So, kung mapapansin nyo, gumamit ako ng symbol na prime. So, para mas madali na matandaan na yung prime is ibig sabihin yun yung after collision. So, ang after collision, sabi dyan, is hindi natin alam kasi yun yung hanapin natin. So, sabi nga dyan, determine the velocity of the truck after the collision. So, ito, unknown yan. So, di natin yan alam. Okay, next. Kunin naman natin yung mga given natin para sa car. Okay, so in this case, gagamitin ko yung subscript na C to represent the mass of the car and all the values na related siya dun sa car. So, gagamitin ko ang M sub C. Okay, so ibig sabihin nito, this is the mass of the car. So, ang mass of the car natin is 1,000 kilograms. And then, yung ating initial velocity ng car, okay, before collision. Ano ba yung velocity ng car before na collision? Ang sabi kasi dyan, nung na-hit nung truck yung car, the car was initially at rest. Kasi sabi dyan, park car. Okay, so naka-park siya, ibig sabihin 0 ang kanyang initial velocity, naka-stop. Now, next, hanapin natin yung final velocity ng car after the collision. So again, gumamit ako rito ng symbol na prime. So ibig sabihin nun after collision. So ang sabi dito sa problem, the impact causes the 1,000 kilogram car to be set in motion at 15 meters per second. So since wala naman binanggit dito na nag-move siya in the opposite direction, so it is safe to assume na yung direction ng shock natin and direction ng car is just the same. So ibig sabihin, parehas positive yung values na gagamitin natin para sa velocity. So ito is 15 meters per second. Okay, so ngayon na meron na tayong mga given. Okay, so paano natin masosolve yung problem? Okay, so alam natin na meron tayong formula that the change in the momentum is just equal to the change in momentum after collision. Okay, so again, total ito. Ibig sabihin, kukunin natin yung momentum muna ng shock plus the momentum of the car. And then, i-equal natin to sa the momentum of the shock and the momentum of the car after collision. So, kailangan natin siyang i-add. Okay, so para hindi nakakalito, unahin nyo munang i-compute yung before collision. Okay, so dito ko na lang siya isusulat. So, before collision. Okay, so mag-compute na tayo. So, yung momentum ng ating shock is equal to mtvt. So, remember, mass times velocity lang ang momentum. So, kung ito, sa substitute natin, so meron tayong 3,000 kilograms times yung ating velocity, which is 10 meters per second. Kaya dito, yung momentum ng ating shock before collision is equal to 30,000 kilogram meter per second. Now, next, i-compute naman natin yung momentum ng car before collision. So, sabi dyan, meron tayong PC is just equal to M sub C, V sub C. Now, nabanggit natin dito na yung V sub C natin is just equal to 0. So, yung initial velocity ng car is just equal to 0. So, automatically, any number that is multiplied to 0 is just 0. So, therefore, ang momentum ng ating car before the collision is just equal to 0. So, next, i-compute na natin yung total momentum before collision. Okay, so the total momentum before collision is just equal to the momentum of the shock plus the momentum of the car. So, sa substitute lang natin to. So, meron tayong 30,000 kilograms meter per second plus 0. So, this one is just equal to 30,000 kilogram meter per second. So, ito po yung momentum natin or the total momentum before collision. Okay, so next, gawin naman natin, isosolve naman natin yung momentum after the collision. So, the momentum of the shock, okay, after collision, again, this one is just equal to mt vt prime. Okay, so, hindi natin alam yung value ng vt. So, kung ito isa-substitute natin, yung mass ng shock alam natin. So, this one is 3,000 kilograms. Pero yung velocity ng truck, yun yung actually hahanapin natin. Kaya ito, iwanan lang natin yung ating variable. Okay? So, gagamitin ko lang yung Vt prime dito. So, next na naman natin yung sa car. So, ito naman yung momentum ng car after the collision. So, meron tayong mc bc prime. So, yung mass ng ating car is 1,000 kilograms times yung velocity ng ating car, which is 15 meters per second. Okay, so ang momentum ng ating car after the collision is equal to 15,000 kilograms meter per second. Now, para makuha natin yung value ng ating total momentum, okay, after the collision. So, mapapansin nyo, naglalagay ako ng prime, ibig sabihin after collision. So, add lang natin yung dalawa. So, PT prime plus PC prime. So, para lang tayo nito gumagamit sa algebra. Okay, so, hindi natin siya pwedeng directly add kasi meron tayong isang unknown value. So, susulat lang natin yung ating expression dito. So, yung PT prime natin is 3,000 kilograms times VT prime plus yung ating PC prime that is 15,000 kilograms meter per second. Okay. Now, yung last step natin, i-equate na natin yung dalawa. Kasi di ba sabi natin, the total momentum before collision is just equal to the total momentum after collision. So, pagsasamahin lang natin itong dalawa. So, yung total momentum na nakuha natin kanina before collision is equal to 30,000 kilograms meter per second. So this is now equal to yung momentum natin after collision. So meron tayong 3,000 kilograms Vt prime plus 15,000 kilograms meter per second. Okay, so para lang tayong gumagamit dito ng algebra, so gagawin natin yung 15,000, itatranspose natin siya dito sa left side. And then pag tinranspose natin siya, magiging negative yung value niya. Kaya mangyayari dito, magiging 30,000 kilograms meter per second minus 15,000 kilograms meter per second. So this is now equal to 3,000 kilograms. And then this is Vt prime. So ngayon i-simplify na natin siya. So 30,000 minus 15,000 is just equal to 15,000 kilograms meter per second. So this is now equal to 3,000 kilograms times Vt. Para masolve natin yung Vt prime, i-divide lang natin both sides of the equation by 3,000 kilograms. Yan. So, ito makakancel na siya. Okay? So, meron tayo ngayong Vt prime is equal to, so 15,000 kilograms meter per second. If you notice, makakancel yung unit dito ng kilograms. So, pag dinivide natin ito sa 3,000 kilograms, ang makukuha nating value dito is 5 meters per second. Okay, so ito na yung velocity ng truck after the collision. So, kung mapapansin nyo dati, yung truck natin nagmo-move siya at 10 meters per second. So, after the collision, ano nangyari? So, yung part ng momentum niya, okay, obviously nawala yung momentum niya after the collision, pero yun namang momentum ng truck is nag-gain naman ng ating car. Kaya yung car natin is nag-move. And kung mapapansin nyo, nabawasan din yung speed ng ating truck. So, this time, gagamit ako ng isa pang example. Pero this time naman, isosolve ko to using a different approach. So, gagawin ko dito is, gamit lang muna ako ng equation and then sa final na tayo magsa-substitute. So, yung kanina nang ginawa ko, medyo matrabaho yun kasi inisa-isa ko siya. Pero kung sa tingin nyo meron kayong risk para malito kapag gumagamit kayo ng equation, pwede nyo gamitin yung approach na ginamit ko kanina, yung una kong pinakita sa inyo. A 25-gram bullet enters a 2.35 kilogram watermelon with a speed of 270 meters per second. And exits the opposite side with a speed of 109 meters per second. If the bullet was originally at rest, then what speed will it have as the bullet leaves its opposite side? Okay, so kukunin muna natin again yung mga values natin based dun sa ating given. So start muna tayo dun sa ating bullet. Okay, so sa case ng bullet natin, meron tayong mass of the bullet. So gagamitin ko is B. Yan, so the mass of the bullet is 25 grams. Now, be very careful dito kasi kailangan parehas yung unit ng mass na gagamitin natin. So, I guess sa case na to, mas madali kasi na i-convert yung grams sa kilograms. So, pag convert natin to sa kilograms, this one is equal to 0.025 kilograms. Okay, so again, very important yung mag-convert tayo ng unit. So, yung 25, dinivide ko lang siya sa 1,000. Kaya ako nakuha yung 0.025. Kasi sa 1 kilogram, meron tayong 1,000 grams. Okay, next, meron tayong velocity ng ating bullet. Okay, ang initial speed niya is 217 meters per second. And then, yung velocity ng bullet natin after the collision, so, lumusod siya dun sa watermelon. So, this time, mas bumagal na yung speed niya. So, ang speed niya is naging 109 meters per second. So, sa watermelon naman, so the mass of the watermelon is equal to 2.35 kilograms. Now, yung speed ng ating watermelon before the collision, so ang nasabi kasi dyan is the watermelon was originally at rest. So, ibig sabihin, 0 to. Okay? So, ang tanong ngayon is, ano daw yung speed ng ating watermelon after the collision? So, pagkatapos na lumusot yung bullet sa kanya. Okay. So, ngayon, gagamitan ko muna siya ng equations. So, dito muna ako magsisimula sa the momentum, the total momentum before the collision is just equal to the total momentum after collision. Okay, so sa-substitute ko lang to. So, yung total momentum natin before the collision, this one is just equal to the momentum of the bullet plus momentum of the watermelon. So this one is also equal to the momentum of the bullet plus the momentum of the watermelon. So lahat to after collision cases. Okay. So, alam natin ng equation for P is just equal to mv. So, gagawin ko lang dito, papalitan ko lang yung equation natin. So, magiging mb vb plus mw vw. So, this one is equal to mb vb prime plus mw vw prime. Okay, so ito yung after collision case kapag may prime. So, titingnan ko muna dito sa aking given kung alin dyan yung equal to 0. Kasi para yon nakakancel ko na siya agad sa equation. Kasi mas madali na i-simplify yung isang equation kapag alam mo ng isa dyan is equal na sa 0. Or kung meron man dyan variables na equal to 0. Okay, so sa case na to, ang equal natin sa 0 is yung initial velocity ng watermelon. So, dito tayo. Ito. Yung VW rito, makakancel na to. Kasi this one is just equal to 0. So, kung equal to 0, ibig sabihin, itong term na to, wala na siya. Kasi any number that you multiply to 0 is just equal to 0. So, ibig sabihin yung aking equation, pwede ko ma-simplify para maging ganito na lang siya. MBVB okay, is equal to MBVB prime plus MWVW. Now, next step, kailangan natin ma-solve yung value ng VW prime. Okay, ito yung hinahanap natin, VW prime. So kung mapapansin nyo, yung kasama ng W is itong term na to. So, itong term na to, para lang tayo gumagamit ng algebra. So, iti-transpose ko lang to sa left side. Okay, and then, kapag tinranspose ko siya, magiging negative yung kanyang value. So, magiging ganito yung equation natin. MB, VB, minus MB, VB prime. Okay, so, ito now is equal to MW, VW prime. Okay, so from here, kung mapapansin nyo, pwede na nating i-divide both sides of the equation by MW. Yan, para ma-cancel na yung MW doon sa ating right side of the equation. Parang matitira na lang natin doon is yung VW prime. Yan, so maka-cancel na siya dito. So therefore, yung final equation natin is VW prime is just equal to MB VB minus MB VB prime over MW. Now, kung gusto nyo pa na i-simplify ito using algebra, pwede pa rin naman kasi pwede nyo i-factor out yung MB. So, magiging ganito siya. So, VW prime is equal to MB. Factor out lang natin to kasi since parehas kang may MB dito sa dalawang term mo. So, ito magiging VB minus VB prime over MW. Yan. So, ngayon na meron ka ng equation, madali na ngayon mag-substitute. So, substitute na natin yung values. So, meron tayong VW prime is equal to, ang mass ng ating bullet is 0.025 kilograms. So, multiply to VB. So, initial velocity natin is 217 meters per second. So, maminus natin yung VB prime na 109 meters per second. Bago natin siya i-divide dito sa MW. So, ang MW natin is 2.35 kilograms. So, again, mapapansin nyo dito, makakancel natin yung kilograms. Ayan. So, matitira na lang na unit is meter per second. VW prime is equal to, so this one is 1.15 meters per second. So, ito yung velocity ng ating watermelon after the collision. Okay, so again, inuulit ko, itong second approach na pinakita ko sa inyo is ginamitan ko siya ng algebra. So, kung comfortable kayo na to work with equations, mas maganda itong gamitin kasi syempre, mas maiksi yung solution mo. Pero kung sa tingin mo, medyo malilito ka sa concept ng algebra o hindi ka masyadong comfortable doon, pwede mong gamitin yung approach na pinakita ko kanina doon sa unang example. So, sana po nakatulong ng malaki sa inyo itong video na to on law of conservation of momentum. And kung meron po kayong mga comments or meron kayong mga questions or meron kayong mga suggestions para sa mga susunod na topics sa physics or sa math na pwede nating gawing YouTube tutorial, mag-comment lang po kayo sa ating comment section. And I'll see you on my next video.